In this session, we shall solve a numerical problem to convert the per unit reactance in one base value to the per unit reactance with another base value. In this problem, we have a generator. It is connected to a transmission line through a transformer. Let me draw the single line diagram. This is our generator. The transformer. It is connected to the transmission line. The generator rating is 120 MVA, 19.5 kilovolt. Its reactance is 15%. The transformer rating is 150 MVA. Its voltage rating is 230/18 kilovolt. But this generator, which is having a rating of 19.5 kilovolt, is connected to the primary of this transformer. So this voltage rating should be written as 18 kilovolt bar 230 kilovolt. Because this 18 kV is close to this 19.5 kilovolt. So we cannot connect 230 kV on the primary side. Its reactance is 10%. This 15% is same as 0.15 per unit. So it is J 0.15 per unit. This 10% is same as 0.1 per unit. So it is J 0.1 per unit. This reactance, this per unit reactance is given with a base of 150 MVA and 18 bar 230 kilovolt. This per unit reactance is given with a base of 120 MVA and 19.5 kilovolt. So these per unit reactances are given with a different base values. We have to find out the per unit reactances on a common base value. Here the common base value to be used in this problem is 100 MVA 230 kilovolt on the transmission line. The new base values are 100 MVA. This is our MVA based new. And the kilovolt based new is 230 kilovolt. This is our KVB new. And these base values are available on the transmission line. And throughout this power system, MVA based new will be 100 MVA. Let me divide this power system at this transformer. Throughout this power system, the MVA based new will be 100 MVA. But this 230 kV will be available up to the secondary of this transformer. But when you move from the secondary to primary of the transformer, this voltage will change. The KVB new will change in this part. From the primary side of the transformer up to the generator, the base kilovolt will change. What is the base kV on the primary side of the transformer? This is how we find out the KVB on LT side, the low tension side of transformer, is equal to the KVB new. This is also KVB new on HT side into the transformer ratio, LT divided by HT. The KVB new on the high tension side is 230 kilovolt. So it is 230 into the transformer ratio. It is 18 divided by 230. So this is 18 kV. So on the primary side of this transformer, the base kilovolt is 18 kV. So for the primary side of the transformer and for the generator, the base kilovolt will be 18 kV. Now we have to find out the per unit reactances on this base value, on this new common base value. Let me draw the reactance diagram of this power system. This is our generator. This is the transformer. The reactance of the transmission line is not given in the problem, so we need not to consider that. Now let us convert these per unit reactances into a common MVA base. So X per unit nu is equal to, this is the formula we are using, X per unit old into kVb old divided by kVb new the whole square into MVAB new divided by MVAB old. Let us find out the reactance of the transformer. The transformer reactance, the per unit reactance can be found out either on the secondary side or on the primary side. If you find out the reactance on the secondary side, this is the kVb you have to use. If you find out the per unit reactance on the primary side, then you should use 18 kV as the base value. Let us find out the per unit reactance on the secondary side. For a transformer, the per unit reactance will be the same both on the secondary side and on the primary side. This is equal to, what is X per unit old of the transformer? J 0.1 into the kVb old, which is the rating of the transformer. It is 230 divided by kVb new. This is our kVb new. This is also 230, the whole square into, what is the MVA base new? This is 100 MVA. Throughout this power system, this is 100 MVA divided by MVAB old is the rating of this transformer, 150. Because this per unit reactance is given with a base of 150 MVA and 230 kV. So these are the old values, old base values. We are converting this into X per unit new with new base values. This is equal to J 0.0667 per unit. Let me mark the value here. J 0.0667 per unit. Now let us find out the reactance of generator. This is equal to, what is X per unit new? X per unit old into, this is our X per unit old, J 0.15 into kVb old is the rating of generator. 19.5 divided by kVb new, this is 18 kV. The whole square into MVAB new, this is our MVAB new. Throughout this power system, the new base value is 100 MVA divided by MVAB old is the rating of the generator. It is 120. And this is equal to J 0.1467 per unit. So it is J 0.1467 per unit. Now we have converted the per unit values with a different bases into the per unit values with a common MVA base.